Good evening, everyone. Welcome to this Embedded System Design, IoT, and PCB Design Masterclass series. I warmly welcome you to the session. Thanks for coming and thank you for your time. First, I would like to welcome the early comers first. Uh, Good evening, Harish Kumar, Srinu, good evening, Jaya, good evening, Jyoti Kumar, good evening, Sajid Khan, Indrajit, good evening, VK, Ankita, and Zainab, and Sanoj Kumar, and Tripti, uh, Sridhar S, and Rastogi, Manish Rastogi, and Jagadhar Singh, Arjit, Shaba, Manidam Bhumi, and Ayush, Jayalakshmi, Vidun, and Meena Shekaran, and Hitesh Parmar, and Manoj Singh, Srilekha, Snega. So, good evening to all. Good evening, everyone. Thank you so much for coming today. And if I am audible, just type yes in the chat box. If I am audible, just type yes in the chat box. I'm waiting for your chat. Good evening, Rajarajan. Good evening, Osman, Diban, Hitesh Parmar, Chiku, Deepti Priya, Rahul Ram, and Gandharva Kulkarni, Pooja, and Akansha Sharma. So, good evening, everyone. If I'm audible, just type yes in the chat box. They wants yes. Thank you, Mudit. Thank you, and thank you, Sonu Kumar. Thank you, Rahul. Okay, let's go for the session. So today, like we are going to learn about the 8051 architecture. Okay, so we'll be covering up the introduction to microprocessor and microcontroller, the difference between a microprocessor and microcontroller, and the types of microcontroller, and the types of microcontroller architecture. Okay, microcontroller architecture, features of microcontroller. We'll be covering up the block diagram, 8051 block diagram, the pin details, and the registers in 8051, and ports, timers, and interrupts, and the counters, and finally, how to design an embedded system design using 8051. So that we'll be covering up. Okay, so these are the things which we are going to learn today. I'll give a short introduction about me, and then we can go for the session. Okay, my name is MK Jeevarajan. Like, if you want to connect with me, I'll send you my LinkedIn link, so you could connect with me on LinkedIn. Okay, I'll post it on the chat box. Give me a moment. Okay. So my primary expertise is on microcontrollers. So I have around 18 plus years of experience, and this session is about sharing my knowledge with you. So if you have any questions, you could post the questions on the end of the session on the live chat, and you could also post the questions on the Facebook group, and you could also send the questions on my LinkedIn. Okay, so I'm happy to connect and happy to help. Uh, I'll give you an announcement, like the attendance link will be available at 9 to 9:15 p.m. Okay, so minimum attendance required to get a free certificate is 27 days. You may get a waiver of 1 or 2 days, but minimum 25 days attendance is required for get a free certificate, and the link will be valid for 1 hour after the event. Okay, so you have to put the attendance form. You have to fill the attendance form before that. For internship candidates, no need to fill the attendance form. All you have to do is after watching the video on the portal learn.pantechsolutions.net, if you have make the payment, like you could use the same email and you could log into learn.pantechsolutions.net. After watching the video, just give complete and continue. Once you complete all the course, then the certificate will be generated, auto generated inside the portal itself. Okay, for some sessions, I'll be using the recorded video streaming for lab classes. Tomorrow's session is a recorded video streaming. Tomorrow I'll be on live on Zoom on the Hub platform, like the Warriors Way platform. So those who had made the payment, like, you could join the live Q&A session tomorrow at around 5:30 p.m. on the Warriors Way Hub. You will receive an email today. Okay, so tomorrow, like, the introduction to Kale, that will be on the recorded session. Okay, so PPT and source code downloads will be available for the paid participants. PPT as a PDF format will be sent through email. For every day, the course material PPT will be sent through email as a PDF format, and you could also get it from the Facebook group. Okay, if you have any questions, feel free to post it on the Facebook group, and feel free to ask me on LinkedIn, and feel free to post it on the live chat at the end of the session. Okay. So today only offer is about like 999 rupees. Like, we have embedded system design, PCB design masterclass, internet of design masterclass at 999 rupees. You have 1 year access to the course, and you could practice, like, you have more than 25 plus projects. You could practice, and you could add it to your resume. Okay. So let's start the day with a mindset lesson. So if you're ready to learn, just type RTL in the chat box. Voice is too low. Yes, let me check my microphone. Give me a moment. Okay, so I'll raise my voice. Like, if you're ready to learn, just type RTL in the chat box. Okay, if you're ready to learn, just type RTL in the chat box. Uh, uh, I will raise my voice. Pooja is telling that voice is slow, and Das is also telling voice is slow. Suthir is also telling voice is slow. I will raise my voice. Like, if you're ready to learn, just type RTL in the chat box. Okay. Oh, thank you, Meena Sekran, thank you, Dinesh, thank you, Amit, and thank you, uh, Vidun, thank you. Okay, so today mindset lesson is about consistency. Okay, the first day we have gone through to decide the goal, to decide what exactly you want. Second day is to change the thought process. Okay, change the thought process and change your attitude. And today is about consistency. Today we have three things. Like, one is the consistency, the second is the focus, okay, and third is the self education. So doing one particular thing consistently for 1 year will be, you will be the master in that area. Okay, so first decide what you want. Once you decide what you want, choose, pick one thing which you have to do consistently on daily basis until you achieve your goal. Okay, do that consistently. Brushing your teeth for 5 minutes, daily matters. Okay, you cannot brush the teeth for 4 hours per day, and you cannot do it after 10 days. You have to do it on daily basis for 5 minutes. That will maintain the teeth. Similarly, consistency is the key. Okay, you have to decide one thing which you have to do in achieving your goal, and do that thing consistently. Okay, so consistency is a key for success. Second thing is the focus. So don't do multiple things at a time. Okay, so that will, you'll be practicing distractions. You'll be good at what you practice. If you focus on one thing, whenever you don't go for multitasking, just one thing, so that will make the habit of practicing on focus on one thing. Okay, focus is the most valuable asset, not the time. Okay, so you just practice focus daily by doing one thing at a time, not doing multitasking. And be aware of which is distracting you from the focus, like the notifications. Okay, you may have multiple apps which gives you notifications, so be aware which apps distracts you from the job, and put it on the silent mode, or remove notifications, or even you remove the app, the email thing. Okay, so have some certain point of time to check your emails, to check your phone. Don't keep on checking your phone often, so that by doing that, you are practicing distraction. Okay, you are practicing distraction, so once you will be good at what you practice. So you practice focus, you'll be good at focus, you will be good at focus. So focus is the most valuable asset, not the time. And the third point is the your formal education which you get from college. Okay, it will give you only the living, like you may get a job, but the self education will bring you more money. If you want to earn more money, then you have to work on yourself. The more you work on yourself, wider the impact will be. Okay, you have to learn on daily basis. You have to self educate yourself, invest on self education, on not only on the skill set, on finance, on marketing, on sales, on everything. Okay, so you have to invest on self education. So this quote is from Jim Rohn. So your formal education will bring you living, self education will bring you fortune. Okay, so these are the three things which I would like to share with you today. So if you found useful, just type useful in the chat box. I'm waiting for chat. Okay, first, before that, let me ask you, like, am I audible? Am I audible? Please type yes in the chat box if I am not audible, if I want to raise my voice, because I'm the maximum volume. So if I'm audible, just type yes in the chat box. If I am not audible, like if my voice is too low, just type no in the chat box. I'm waiting for a chat. Thank you, Jitesh. Thank you, Mrunal. Thank you, Das. Thank you, Abhay Kumar. Thank you, Mudit Agarwal. And uh, am I audible? Am I audible? Okay. Just type yes in the chat box if very low. There are some comments which tells me that it's very low, but I'm the maximum like maximum volume. Okay, so anyhow, I'll raise my voice. If you found that if my voice is low, just put in the chat box. So I'll be going through a chat for every 5 minutes of time. So I'll raise my voice again. Okay, so if you so I'll go through the chat for every 5 minutes. If you want me to repeat, just type repeat in the chat box. If you're clear on the topic, just type clear in the chat box. Okay, so let's go for the session. So what is a microcontroller? A microcontroller, it's a smaller computer which has a ALU unit, okay, and every peripherals on a single chip, on a single integrated circuits, okay. So it's a smaller computer, like the RAM peripherals, the memory, the interface peripherals like the UART, okay, everything is on a single chip. Peripherals like controller area networks, UART, timers, and counters, everything is on a single chip. So that is a microcontroller. It's a smaller computer. Okay. Whereas microprocessor, you have to interface everything externally, like RAM, ROM, a timer, and serial communication port as externally. It's meant for general purpose. Mostly it meant for general purpose. Examples are 8085, 8086, and even the Broadcom chip from the Raspberry Pi board is a microprocessor. Okay, so everything you have to do it externally. Pentium 4, Intel, AMD processors or microprocessors, you have to interface everything externally. Whereas microcontroller, everything is available on a single chip, on a single package. Okay, you may have different package like dual inline package and quad flat package, but everything is on single chip. So it's meant for single purpose, whereas the microprocessor is for general purpose, and it is expandable and it is versatile. Okay, so that's the advantage of microprocessor. It could do complex mathematical calculations, whereas microcontroller, it's for single purpose. Okay, so coming to the types of microcontroller, based on bits, you have 8-bit microcontrollers, 16-bit, and 32-bit microcontroller. Like based on the mathematical calculations it can do, there are different types. And based on the internal memory and the external memory, there are different types. And based on the instruction set, RISC reduced instruction set computers and CISC computers, you have different types. And based on the architecture, like the Princeton architecture and the Harvard architecture. So Princeton is a one-human architecture, okay, and the Harvard architecture, both are the universities, like they define the architecture. So based on the architecture, you have different types. 8051 is Harvard architecture, whereas 8085 is Princeton, okay, it's one-human architecture. And based on family, like the core, the 8051 is a core, PIC is a core from Microchip. So every company, they manufacture the core, they manufacture the ALU unit. Okay, it's an IP. IP stands for intellectual property, like it's a core, where the chip manufacturers, they purchase this core and they manufacture their own chipsets, their own chips, integrated circuits. 8051 is the core from Intel. Okay, PIC core is from Microchip, from the company Microchip. ARM is a core, it's from ARM company, but they do not manufacture any ICs, integrated circuits, but they sell the core to different manufacturers. They sell to NXP, they sell to Texas Instruments. Okay, there are a lot of manufacturers. They purchase this core and they manufacture the integrated circuits. So you have based on the family, you have different microcontrollers. Okay, so these are the types of microcontroller. RISC stands for reduced instruction set computers, and CISC for complex instruction set computers. Mostly the RISC architecture, like the instructions will be completed in a single instruction cycle. Okay, so RISC. Whereas for CISC, it takes multiple instruction cycle. So coming to the 8051 family of microcontrollers, you have 8031, 8051, 8052, 857, 8751. Okay, these are the basic. As I told you, like it's a core which was purchased from Intel, and there are a lot of manufacturers. So the peripherals, some manufacturer, they will have different peripherals. Like some manufacturer, they also have the CAN controllers on 8051. They have 2 UARTs and they have USB port. You have to check with the microcontrollers. Dallas Semiconductor has 2 UART, whereas the other manufacturers, they have CAN, even Microchip, they manufacture 8051 core, okay, microcontrollers. So the basic ROM, like 8031, there is no ROM, like it is volatile. 8051 has 4 KB ROM, flash memory. 8052 has 8 KB. Okay, RAM is the random access memory, which is volatile. Okay, when you power off, the program will go off. That is 128 byte, 256 and 128. And timers, you have 2 timers, and 8052 you have 3 timers. IO pins is 32 pin IO, and serial port is 1, and interrupt source is 6, and 8052 you have 8 interrupt source. You also have more interrupt sources. You have to check with the manufacturer. Okay, is that clear so far? The difference between the microprocessor and the microcontroller, and what is microcontroller, and the types of microcontroller, and the 8051 family of microcontrollers. Is that clear? Just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. Yes, Princeton is one human. Princeton is university, like it's one human architecture. Sapna is telling like Princeton is nothing but one human. Yes. UART stands for Universal Asynchronous Receiver Transmitter, like it's a serial port. Okay. So I will tell you the interrupts. Like we have a slide for that. Akhil Raj, like we have a slide for that. I'll tell you. Is that clear? Just type clear in the chat box. We can go for the next slides. If you want me to repeat, just type repeat in the chat box. Nitin is asking for repeat, and Manushri Joshi is also asking for repeat. Okay, so Hari Prasad. So this is a basic. So you just go through the video again. Okay, so I'll go for the next slides because we have a lot of things to cover today. Okay, so coming to the architecture, the Von Neumann architecture and the Harvard architecture, the CPU is connected with the program memory and data memory by using the same address bus and the data bus. Since it's used same address bus and data bus, it could either fetch the program or either fetch the data. Okay, it could do anything only one at a time, program or data, because it uses the same memory space. The program and data uses the same memory space. Whereas for the Harvard architecture, it uses different address bus and data bus for program and data. There are two advantages on this. Okay, it could simultaneously fetch the program, simultaneously fetch the data memory. That is one. Number two, like it could have different bus width. Okay, since address bus, the program it could have 16-bit, whereas for data it could have 8-bit. Whereas for the Von Neumann architecture, since it's same, the address bus and data bus, it should be on the same bus width wide. Okay, so efficient way of mathematical calculation will be done on the Harvard architecture. Most of the DSP processors, most of the latest microcontrollers or the Harvard architectures and the super Harvard architectures, they have modified a lot on the Harvard architecture. So most of the processors are now using Harvard architecture. Okay, I'll go slow. Sandeep Solanki, I'll go slow. Okay. So coming to the important features of 8051, it has 4 kilobytes of ROM. ROM stands for the non-volatile memory, read-only memory, where you store the program data. Okay, 128 bytes of RAM, where you store the data memory, and 4 8-bit of IO ports, 4 8-bit ports. Okay, GPIO ports, 4 ports are there, port 0, port 1, port 2, and port 3, and 2 16-bit timers. Actually, it's a 8-bit microcontroller, but it uses 2 registers for storing that 16-bit. Okay, so 2 16-bit timers are there. Serial interface is there. Serial communication, that's UART. And 16.4K, we have you could interface external memory. Okay, that space is 16.4K external core memory space and 16.4K data memory space. You could add. Okay, so this is the block diagram. So if you check this block diagram, you have the interrupts. You have you have the on-chip RAM, on-chip ROM is there. Okay, that is the this is the 4 KB ROM, 128 bytes data memory, and 2 16-bit timers is there. And then we have the GPIO. We have the external interrupts as well as the internal interrupts. Internal interrupts is like from timers, from UART, like, okay, and the serial port So you have the 4 IO ports, serial port, timers, and on-chip RAM, and the oscillator. Oscillator, you could give frequency from 4 megahertz to 30 megahertz. Okay, so maximum speed is 30 megahertz. Mostly widely used was 11.0298 megahertz, but you could give for 4 megahertz to 30 megahertz. Okay, so this is the pin detail. So if you check out the pin detail, I will explain you all the pins, like from port 1 to port 8, from pin 1 to pin 8. It is port 1. It is a dedicated IO pin. There is no multiplex pins in this port. Port 1 to port 1.7. It is dedicated. Okay. Port pin 10 to pin 17 is port 3. It has some multiplexed signals, like multiplexed pins, like the serial port. The RxD and TXD stands for serial port. Port 3.0 and port 3.1 is serial port, and it could also be used as GPIO, general purpose input output. And 3.2 and 3.3 is for the external interrupts. We have two interrupts, that is interrupt 0 and interrupt 1. Two interrupts, that's 3.2 and 3.3. Okay, 3.4 and 3.5 for the timers. For T0 and T1 are the two timers to count for the counting sequence. I will explain you later in the next slide. And write address strobe and read address strobe is for 3.6 and 3.7. This is used for accessing the external memory, to read and write from the external memory. Okay, so XTEL1, XTEL2 is a pin where you have to interface the crystal oscillator, like 4 megahertz to 30 megahertz. And we have the ground pin and VCC pin. VCC you have to give 5 volt power supply. And 21 to 28 is port 2. That is address pins. Okay, again it is dual purpose pin. And this is also dual purpose. Okay, port 1 is dedicated pin, dedicated GPIO. And we have 29 and 30 and 31 is program store enable and ALE pin and EA pin. ALE stands for address slash enable, to decode the address bus address and the data by using a latch. If ALE is 1, it decodes the address. If ALE is 0, it decodes the data. Okay, because address and data is mixed here on the port 0 and port 7. Okay, for decoding that, you could use the ALE. EA pin is used for if you want to boot the program from the internal memory, you could use EA pin. Should be high, it should be connected to the VCC. If EA pin is connected to the ground, it will boot the program from the external memory. Okay, so that's EA pin. So port 0 and port 7 is the GPIO pin, as well as it also has the address as well as data. You could use the ALE to decode the address and data. And this pin, port 0 to port 0.7 is open drain. Okay, it's open drain. So you have to, if you want to use that as a GPIO pin, you have to use a pull-up resistor. Okay, so is that clear? Is this pin details is clear? Just type clear in the chat box. If you want me to repeat, I will repeat. Serial Cartesian, like serial interface is used. Serial interface is used to, is a type of communication which is used for, you could either use for communicating with other microcontrollers or for other devices like Bluetooth or GPS, like that. Even you could download the program. Is the through in-circuit serial programming, you could download the program through the serial port, the port 3.0 and 3.1. Okay, so repeat EA pin. Okay, I'll just repeat. A lot of repeat is there. I will repeat. Okay, so first I will repeat the special pins. Okay, EA pin stands for, if you want to boot whenever you switch on the microcontroller, the program boots from the on-chip memory or from the external memory, depends upon the EA pin. Okay, the EA pin tells you, like, if the EA pin is, if you connected EA pin to VCC, like it boots from the on-chip memory. If you want to boot from the external memory, then EA pin has to be connected to the ground. Okay, so an ALE is used for address latch enable, because we have some multiplex signals here, address and data from 32 to 39. When you, these pins address and data is used only when you use an external memory. Okay, when you have an external memory, you have to give address and data. Okay, so here you're using the same IO pins for address and data. To decode that, you need this ALE pin, address latch enable. So okay, so when address latch enable is 1, it decodes the address. You have to give that to a latch. Okay, and when it is 0, you will get the data. And PSEN is for external memory. Okay, program store enable is to access the external memory. This port 3.0 to 3.7 is the multiplexed signal. You can also use as a GPIO. GPIO means general purpose input output. You could connect LED or switch, like that. It also serves a special function. Okay, like 3.0 and 3.1 for serial communication, RxD and TXD, that's UART. And 3.2 and 3.3 for interrupts, interrupt 0 and interrupt 1. And 3.4 and 3.5, these are external interrupts. Okay, 3.4 and 3.5 is for timers, T0 and T1 for timers, and 3.6 and 3.7 for read and write for the external memory. So XTEL1 and XTEL2 for the crystal. Okay, for giving input to the crystal. And port 1 is for the port 1 is a general, there is no multiplex, it's dedicated for GPIO. Is that clear? Just type clear in the is that clear? Just type clear in the chat box. Okay, is that clear? Just type clear in the PSEN is for program store enable, like it's for the external memory. Okay, it is used for the external memory. Is that clear? Just type clear in the just type clear in the chat box. Yes, you could use I2C protocol. There is no dedicated I2C. You have to do that in a software. Okay. Crystal frequency is, you could vary from 4 megahertz to 30 megahertz. Widely used was 11 megahertz. So you could also, if you want a dedicated SPI and I2C pins, there are certain manufacturers, they have a dedicated pin for I2C and dedicated pin for SPI, and even for CAN. CAN you could check. You could check from DigiKey site, digikey.in or digikey.com if you are an international customer. Okay. Which ports? Okay. So, Dhanashri, I will explain you the vector address and interrupts in the upcoming slide. Dhanashri is asking for vector address and interrupts, that I will explain in the upcoming slides. Okay. So, let's go for the next slides. Next one. So, coming to the registers, coming to the 84 CPU registers, you have an accumulator which stores the data of the results of the operations from the ALU unit, and B registers, which is specially for the multiplication and for division. Okay. And program status word to which stores the status of the ALU, okay, the overflow flag and everything. And stack pointer, 8-bit stack pointer is used to store these is the location of the address of the stack. Like whenever the interrupt occurs, like it stores the program counter address on the stack pointer. And 16-bit program counter which contains the address of the instruction which has to be executed next. Okay, so this program counter like will stores the information of the address which has to be executed. Like when you reset the processor, it starts from 0 location. Like, so the only the program counter will have the address of the instruction to be executed. Okay. Data pointer contains the address of the external memory locations. Okay. I just repeat, accumulator, it stores the results of the ALU. Okay. And B registers is used only for multiplication and divisions. And program status word, it stores the status of the ALU, like the overflow flag and everything. And stack pointer is used to store the address of the, like whenever the interrupt occurs, it wants to store the current location of the program counter. Okay, so that will be stored in the stack pointer. And program counter, it stores the address of the next instruction to be executed. And data pointer, like it gives you the address of the data pointer is used for the external memory access, like it stores the address of the data. Okay. So apart from this, you also have these special function registers, like you have registers for timers, registers for serial ports, and register for interrupts. So when you use an Arduino IDE, you will not be using this because everything is internal, like everything is stored as a library file. But when you write as a bare metal programming, like when you write from basic, like you should be aware of the registers. Only if you are aware of the registers, like by using the registers, you will be for sending the serial port data in Arduino IDE, you can send it on a single line. Okay, whereas for 8051, like you have to write a program by using the registers, like serial port registers. You have to use and you have to send the data, check for the overflow, check for the interrupt, everything. Okay, so serial port, it has separate registers, interrupt has separate registers, and timers also have separate registers. So we'll be going through the registers in the upcoming slides. Okay, coming to the ports, we have 4 ports: port 0, port 1, port 2, and port 3. As I said, port 0 is open drain. Like to use that as a GPIO, you have to use a pull-up resistor, 10K pull-up resistor. And port 0 has dual port, like it also contains the address and data like it is used for to send address lines and for data lines. Okay, to interface with the external memory. And port 1 is a dedicated IO port. Port 1 is a dedicated IO port, and port 0 and port 2 is a dual purpose port. Port 3 is also dual purpose. Okay, port 3 is also dual purpose. So whenever you press reset, by default the port will be as an output port. Okay, so you have to set in the program to make it as an input. If you want if you want to define that as an input port, you have to set it in the program. By default, when you reset the microcontroller, like, it will be the output port. Okay, so these are the alternate function of P3, like 3.0, 3.1 is serial communication, RxD and TxD, and 3.2 and 3.3 is interrupts, 3.4 and 3.5 is timers, timer T0 and T1, and 3.6 and 3 is external data memory write strobe, like write and read strobe. Okay. For timers and counters, coming to timers and counters, A51 has two timers and counters. Okay, so timers, it's used for generating delays. For example, you want to introduce a delay on the program, then you could use timers for generating delay for 50 seconds or 50 seconds or 100 seconds. Okay, to generate a delay for giving a on time and off time. Okay, for PWM, you could generate delays by using these timers. The purpose of the counter, like we have separate pins where you could interface a proximity sensor kind of thing, which counts the pulses from these sensors. Okay, so and you could count the number of rotations or number of persons entering the room. That kind of applications you could do with the event counter to count the external inputs. Okay, so 8051 has two 16-bit timer registers, but it has two 8-bit registers, like TH0 and TL0. By using that 8-bit registers, they are making a 16-bit timer, because 8051 is a 8-bit microcontroller. Okay, so but the registers, but we have the timer registers of 16-bit. By using the two 8-bit registers, TH0 and TL0, and TH1 and TL1, and the T mode and Tcon register is shared by the it is a 8-bit mode register, but it was shared by both the timers. Okay, T mode and Tcon mode, because it has 4 modes, which I'll be covering up in the next slides. So for timer, is that clear so far? Just type clear in the chat box. I'm waiting for your chat. Port 0, Javed Khan is asking for port 0. Port 0, see, port 0 is open drain. Okay, it's meant for that, because some applications needs open drain to interface with the logic. So open drain cannot be used for GPIO. It will be in high impedance state. So you need to attach a pull-up resistor to make it as a GPIO. If you want to use port 0 as GPIO, then you have to use this pull-up resistors. The rest of the ports, they have the internal pull-up. Okay, so they have the internal pull-up, it will work. But for this pin to use as a port 0 as a GPIO, you need to use a pull-up resistor. So thank you so much. Let's go for the okay. So for timer, you have to set the initial value for the registers. Okay, and then the timer counts up. It uses the internal clock, the crystal clock machine cycle for the counting. Once it reaches, then it denotes the timeout. Okay, whereas for the counter, it takes from the pin like P3.4 and 3.5 is for the counter. Like you could give the external switch or external sensors, proximity sensor kind of thing, or digital sensors. You could directly connect to this, and you could the display, you could give it for an LCD or a UART or anything like that, and you could count the number of events. Okay, so the T mode registers, like the same registers used by both the timers. Okay, timer 0 and timer 1. The LSB will be for timer 0 and timer 1. So M0 and M1 is used for the mode, for selecting the modes, as it has 4 modes: 13-bit timer mode, 16-bit and 8-bit auto reload, and split timer mode. The widely used was 16-bit timer mode. Okay, 16-bit timer mode, it can count up to 0 to 65535. The maximum value a 16-bit can have, whereas the 8-bit auto reload and the split timer mode can count up to 0 to 255. In split timer mode, it can have 2 timers. You can have 2 timers on split timer mode. On 8-bit auto reload, it is an 8-bit timer, like it can count up to 0 to 255. Okay, 13-bit timer mode, and the most widely used was 16-bit timer mode. So in order to configure which mode you want, you need to use this M0 and M1. This one, M0 and M1. So it is bit addressable. So it is not bit addressable. Like you could use this M0 and M1 to choose the timer modes. Okay. So is this a timer mode is clear for you? Is the timer mode is clear for you? Is the timer mode is clear for you? Okay. Give me a moment. Okay, so I'm waiting for a chat. Okay, as Swanshing is asking for repeat. Okay. Okay, clear. Okay, Dhanashri is clear. Okay. Okay, so serial port. Coming to the serial port. Okay. Coming to the serial port, RxD and TXD pins of the 8051. Is there are, we have two pins to send the serial communication. Okay, so these pins are TTL compatible. TTL compatible means like TTL logic is for 0 it is 0 volt, and for 1 it is 5 volt. That is TTL compatible. To make them to RS232 logic, RS232 compatible, because if you want to connect with PC, you need a driver for that, max 232 driver for that. That will convert this TTL level to the RS232 level. Whereas RS232 level, it is 0 volt is plus 3 volt to 25 volt, plus 25 volt, and 1 is minus 3 volt to minus 3 to minus 25 volt. Okay, so you need a max 232 driver for this to convert this TTL level to the RS232 level. If it is a 5 volt 8051, okay, there are certain 8051 you also get for 3.3 volt. You have to check with the manufacturer data sheets. In case if you use a 3.3 volt, then you have to use max 3232. Okay, max 3232 driver for that. So for serial port, you could use SCON registers. Okay, serial control registers, timer and TMOD for timer mode registers. Okay, and TXD pin is connected to the TXD pin should be connected to the RxD, and RxD pin will be connected to the TXD. It's a cross connection. Mostly it is on cross connection, and like you have to use the serial control registers for transmit interrupt and receive interrupt, and these details like how to write a program for UART by using these registers, that will be covered up on the UART session. Okay, and the timers also will be covered. So is that clear? Serial port is clear. Like 8051, I just repeat. We have two pins, RxD pin and TXD pin, and actually for serial communication they use three wires: RxD, TXD, and ground. Okay, so these levels, the output level from the 8051 will be on TTL logic. TTL logic is 0 is 0 volt and 1 is 5 volt. Whereas if you want to interface that with a PC, personal computers, then it should be converted to RS232 level. So the RS232 level is for 0, it is plus 3 to 25 volt, and for 1, it is minus 3 to minus 25 volt. So in order to convert that, you need a driver called max 232 if it is a 5 volt. If it is a 3.3 volt, you need to use max 3 to 32. Okay. So for writing the code for UART, you need SCON register, like serial control registers. It's a 8-bit registers, like where SM0, SM1 is a serial port mode specifier. Okay, and set clear reception, and SCON3 is not widely used, and this is transmit interrupt flag and receive interrupt flag. So we'll be going through how to use these registers to write the code on we have a separate session for that. So let's go for interrupts. Okay, so TTL, transistor level logic. TTL stands for, I think TTL stands for a transistor level logic. Okay, so let's go for transistor logic, I think. Okay, okay, let's go for the 8051 interrupts. An interrupt, like whenever an external event or internal event occurs, it goes for the interrupt service routine. Okay, it's just like it's just like a telephone call. When you get a telephone call, you suspend the work. Give me a moment. Just give me a moment. I think I have. Okay, so an interrupt, like you have whenever an interrupt occurs, you just go for interrupt service routine. Okay, it's just like whenever you get a telephone, like you suddenly stop the current work and you go for answering the phone call. It's just like that. So microcontroller like can serve interrupts and like they it can give to access, it could give the ALU access for external devices by using interrupts or through polling. Okay, so interrupt service routing. So what happens is you have you have multiple, like you have external interrupts and you also have internal interrupts in the 8051. Like internal interrupts, like you what transmit flag, you what receive flag, and the timers has interrupts. Okay, and so normally what happens when microcontroller gets an interrupt, it checks for the address, vector address, interrupt vector address, and it goes to the address, and it stores the it completes the current instruction, and it stores the program counter. It stores the program counter location to the stack pointer, and then it jumps to the interrupt service routine. Okay, it executes the interrupt service routine, like it gets the address from the interrupt service, the vector table, okay, which I'll show in the next slide. It start executing the instructions until it gets the instruction called ready. Okay, so return interrupt. So return from the interrupt. So it executes the instruction. Once it gets ready, like returns to the it turns back to the it gets the location from the, it pops the stack pointer and gets the program counter location, and it starts executing the instructions. Okay, I just repeat what happens here. Whenever an interrupt occurs, okay, it finishes the current instruction, and then it pushes the program counter instruction. Program counter will have the instruction, will have the address of the instruction to be executed next, that it put to the stack pointer, and it go for the interrupt service routing. So interrupt service routing is nothing but a certain part of the code is located at certain place. Okay, so so every interrupt will have an interrupt location, will have the location where the interrupt service routing has to be executed. It goes to the location, it executes the code until it gets the ready instructions. Once it gets the ready, the return from interrupt instruction, it comes back and it gets the program counter. It gets the location from it gets the next instruction to be executed from the stack pointer. It pops up the first is the push. It stores the pop. It gets back the program counter. Okay, and it executes the instructions. Is this clear? Is this clear? Just type clear in the chat box. Sinu, like I have sent the PPT. I have sent the PPT on the email. I'm not sure. I have not posted on Facebook, but I will post it on Facebook today. Okay. Is that clear? Just type clear in the chat box. Is the interrupt steps in executing an interrupt is clear? Just type clear in the chat box. Is that clear? I'm waiting for a chat. Is that clear? Okay, thank you, Avinash. Thank you, Navneet. Thank you, Shaurabh. Surya, thank you. Mahak, thank you. Aryan Shivu, thank you. Prasanna Kumar, thank you. Vikash Gupta, thank you. Arjit is telling no. Okay. Vikram, thank you. Okay. Shinu Guglani, like I have sent that PPT of second class through email, but on Facebook group, I will send it through the, I will send. Okay, I'll go slow. Bola is telling to go slow. Okay. Jahir, I have sent the PPT through email. You please check the spam folder, or you might found it on the first line like of the email. Okay, so interrupt source, like you have 6 source of interrupts. Reset, whenever you press reset, it default goes to 0 location and it executes the interrupt from 0. Timer 0 overflow, timer 1 overflow interrupts is there. External interrupt 0, external interrupt 1 is there. Other than that, serial port inputs, serial port events. Okay, for transmit flag interrupt and receiver flag interrupt. Apart from this, the enhanced version of 8051 has more than 22 sources of interrupts for ADC and for other sources. So, but the basic 8051 has only these 6 sources of interrupts. Okay, reset, timer 0 overflow, timer 1 overflow, external interrupt 0, external interrupt 1. Okay, so coming to the interrupt vectors. So every interrupt will have the vector, like will have the location of the starting address location of where you place the code. Okay, for example, like if external interrupt 0 occurs, it goes to this location and it started executing the code from this location 003. Okay, timer 0, when timer 0 overflow occurs, it goes to this location and started executing the location until it executes the instruction until you have the ready instruction. Okay, once its ready instruction is there, it comes back again to the it takes from the stack pointer and comes to the original position. Okay, so that's the interrupt vector. So this will change from for different microcontrollers. Like ARM will have this interrupt vectors on 8051. So this is the location. Like whenever an interrupt, whenever an interrupt occurs, so the interrupt service routine will be placed at this location, at 003. For external interrupt 0, it is 003. For external interrupt 1, it is 0013. This answer is for Dhanashri. I think she asked for interrupt vectors. Dhanashri. Okay. So if you got the point, you please comment on the chat box. Okay. Uh, so I'm waiting for chat. Okay. So coming to the interrupt priorities, they have the default priority order, but still you could put the interrupt in high or low on the IP register. Okay, priority registers. You could make it the interrupt as high, so that when you set it high, it will give preference for the high priority. The processor will give preference for the high priority. Okay. So you could also have nested interrupts. Okay, nested interrupts, for example, you have the processor or a controller and you get an interrupt. So now the processor goes for the interrupt service routine. Now you get a higher priority interrupt. Okay, so what happens, it again goes back to the high priority interrupt, service for the high priority interrupt, then return back to the low priority interrupt, service there for the low priority interrupt, and then returns back to the original location. So this is called nested interrupts. Okay, you could have nested interrupts. So whenever a high priority interrupt, whenever an interrupt occurs, it goes for the interrupt, and again you get an interrupt from the high priority, it goes for the high priority interrupts and service there and comes back, service the low priority interrupt service. So this is called the nested interrupts. So it also supports nested interrupts. Okay, I'll go slow. Okay. So so coming to ESD using 8051. So is that clear? Is that clear? I'm waiting for a chat. Is that clear? Just type clear in the chat box. If you want me to repeat the interrupts, just type repeat in the chat box. Is that clear? Is that clear? Please make a question on every attendance link. Okay. Vignesh. Okay. Sir, external interrupt. See, external interrupt means like Panchakshari, like external interrupt means like you have a dedicated pin where you could connect an external pin. Like it may be like external interrupt, you may give it from a sensor. Okay. So that pin, like you may give it to the sensor. So when that interrupt occurs, it will go for the interrupt service routine. So latch is used. What is latch? Latch is used to decode the address as well as data. Okay, it's a separate IC integrated circuits which is used to decode the. Whenever you give the ALE pin, you just search for latch on the Google, like the pin details, like the IC integrated. You will get separate integrated circuits. The part number will be like the latch IC part number will be like. Okay. So latch, I will let you know the latch IC part number. Okay. Okay, I'll go slow. Okay, I'll go slow. So let's go for the ESD design. Okay, ESD design using design using 8051. Okay, so and so this is the board which we are going to design in PCB, which we are going to design in the PCB masterclass, PCB design masterclass. That the last 10 days, So it's an 8051 board. I will explain you about this board and how the design has been done. Okay, this board has the features like this part. This part is called the power supply part, like where it gets the input from the a power supply, a wall mounted power supply, like AC DC AC power adapter or a DC power adapter, because it has a bridge rectifier, so it could also accept an AC adapter as well as DC adapter. So this is the power supply part. And this is the USB UART part, FT232 part. USB UART stands for like if you want Siri, if you want to like it's a if you want to like interface a serial port via an USB to a laptop, then you could use this serial converter, USB serial converter, USB to UART, which uses FT232. And this is the RS232, like it will give you the RS232 port. Again, you could connect with the PC, personal computers. Okay, so if normally like this laptop does not has this serial port, they have only USB port, so you could use FT232 for that. And reset, and to study the interrupts, we have two switch which is connected to the interrupts, INT0 and INT1. So when you press this, it will go for the interrupt service routine interrupts. So it is connected to the INT0 and INT1 to study the interrupts. Okay, and we have a crystal here, 11.092 megahertz, and capacitors for that. And this is a SIP resistor. SIP resistor for pull-up, 10K SIP resistor. It's a resistor for 10K SIP resistor for pull-up. And this is a decoupling capacitors. Okay, so if you check this, if the first thing is the 8051. You have to take the 8051 and you have to make the schematics. And this is the schematics for the power supply design. Okay, this is the schematics for the power supply design, like where this is a DC jack and it is connected to the bridge rectifier. It looks like this. Okay, bridge rectifier looks like this. So you will get a DC here. Okay, and it to regulate that, for example, you give 9 volt AC. To regulate that to a 5 volt, you use a voltage regulator, 7805 regulator. TO220 stands for the package. Okay, and 470 microfarad 24 volt is a nice capacitor, like the decoupling capacitor here, 0.1 microfarad decoupling capacitor. And this is LEDs for indication. Okay, 330 ohm is for current limiting resistor for the LED. And we also have USB port to get from the USB power supply. So is the power supply design is okay? Is a clear power supply? ESD stands for embedded system design. Okay, is the power supply design is okay? Power supply design. A bridge rectifier, thus like the bridge rectifier is used if you use a AC power adapter, otherwise not needed. Okay, if you are going to use a DC power adapter, the bridge rectifier is not needed. If you're going to use an AC power adapter, then you need a bridge rectifier. Is the power supply design is clear for you? Is the power supply design is clear for? Just type clear in the chat box. I'm waiting for a chat. Okay. Okay. Pushotman is telling clear. Okay. Is the power supply design is clear for you? Okay. Prashana Kumar is okay. Sweta is okay. Thus for DC not needed. Okay, for AC only if you have a AC power adapter, you need the bridge rectifier. For if you are going to use DC power supply, then bridge rectifier is not needed. But sometimes if the customer has a AC power adapter, and he could still use this if you have a bridge rectifier. Okay, so the next thing is connecting the VCC and ground. Okay, the first thing you have to do is connecting the power supply for the microcontroller. The next step is to connect the reset circuit. Okay, to connect the reset circuit. And next step is to connect the crystal. These three connections, the power supply, the reset circuit, and the crystal. Okay, if this is okay, then the microcontroller is ready to function. To make the microcontroller to function, you need to connect the reset circuit. So whenever you want to reset, you give a reset signal. So see, there are two ways to reset the microcontroller. The one way is to power off the device and power on the device. So that will reset the microcontroller. If you want to do by using a switch, then you have to send the reset signal to the reset signal by using a push switch. Okay, when you press the switch, based on the it is here it is reset is active high, I think so. Reset is active. Reset is active high. Okay, you have to give a high signal. You have to give a high signal for this. Is active high. When you give a high signal for this, when you give a pulse for this, the processor will reset. When processor will reset, it starts executing the instruction from 000. Okay, and so if, for example, if you want to blink a LED, you need to give these three connections. First, you give the VCC and ground. The second thing is to give the reset switch, and third thing is to give the crystal. Okay, crystal is like heart of the microcontroller. Like you give the crystal supply to XL1 and XL2. So now if you want to use port 0 as GPIO, then you have to use a SIP resistor here, pull-up resistor, 10K pull-up resistor here. Okay. And next is, if you want to interface a serial port, then you connect 3.0, 3.1 to a max 232 IC. So that is a driver IC, which will convert the TTL level to the RS232 level. Okay. 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 So is okay. So I'm waiting for a chat. Is that clear till now? Like, I'll check for the chat. Give me a moment. I'll check for the chat. Diksha is asking for, don't we use transformer? Like, see, if you're using a 230 volt and transformer is used to step down, but if you use an adapter, okay, adapter like DC adapter or AC adapter, that has a part which converts to 230 volt to 5 volt AC or DC. We have put a bridge rectifier to convert. If you're using a AC adapter, to convert that to a DC, we have used a bridge rectifier. But if you're going to use only DC adapter, then no need of bridge rectifier. You can eliminate the DC rectifier. Okay, this answer is for Diksha. And please explain more detail. Ajay is asking for explain for more details. Ajay Sadar, I'm not sure what to explain. In 7805 is voltage regulator. Yes, 7805 is voltage regulator, because if you use a 9 volt adapter, it will regulate to 7805. Okay. So is that clear? Do you want me to repeat, or just type clear in the chat box? I'm waiting for chat. Okay, so I'll just repeat. See, the first thing to design this board is to design the power supply design first. Okay, the power supply design contains, this is a DC jack here. If you look out here, the DC jack. The next is the bridge rectifier, and we have this is the 160. This is the 250 microvolt. Okay, 470 microfarad. Sorry, this is the 470 microfarad. Okay, and this is 0.1 microfarad disk capacitors. These are electrolytic capacitors. Okay, and this is for the current limiting resistors, and this is for the LED. So this is the power supply. This is the design 420 microfarad 25 volt voltage regulator to regulate the voltage. Input is 9 volt AC. Or 9 it can accept 9 volt AC or DC. Okay, so it regulates, and this is for LED indication. So the first step is to give the VCC and ground to the microcontroller. The second step is to give the reset switch. Okay, to reset. Whenever you push the switch, it resets the microcontroller. The third step is for giving the crystal for 11 point. It can accept from 4 megahertz to 30 megahertz, 11.0592 megahertz. You give this circuit. Okay, so once it is done, now the microcontroller is ready. Okay, so you could program. To program, if you're going to use in-circuit serial programming, then you need a serial communication. For that, you use this serial port. Okay, so now through serial port, you could download the program to the microcontroller. Okay, and this is for pull-up resistor for port 0, for making that to use that as GPIO. The next is EA pin and PCN pin. Okay, if you're going to boot from the program memory, then you put up 8.2K pull-up resistor to VCC. Okay, PCN, so that it boots them. There is no external memory here, so I make it pull up PCN to VCC and EA pin to VCC, so that it boots the memory from the program memory, from the on-chip memory. Okay, from the on-chip microcontroller. If you put this to a ground, then it will boot the memory from the external memory. Okay, so external memory. So so we have a product with a monitor code, which the code is fused on the external memory. In that case, we have pulled this down to ground. Okay, so crystal is only crystal provides the source for the microcontroller, because based on this clock, it gives you the machine cycle which executes instruction. Crystal is like the heart of the microcontroller. Okay, without crystal, see, if the microcontroller is not working, like, you have to check 3 things. First, you check whether you are giving the proper VCC and ground to the VCC pin and the ground pin. Second, you check for the short. Third, you check for the reset, whether the reset is correct. Sometimes if reset is high all the time, then the microcontroller will be reset all the time. Okay, and the third and the fourth is, you have to check the by using an oscilloscope, you have to check the crystal whether you are getting the proper clock. Okay, if you get the proper 11.09 megahertz crystal signals and the sine signal, then the microcontroller will work. Okay, if you're clear with this, just type clear in the chat box. If you're just clear, this 33 picofarad, this values you'll get from data sheets. This 33 picofarad, whether to put 33 picofarad or 20 picofarad, you will get from the data sheet of 8051. Okay. So is that clear? Just type. I'm waiting for a chat. Is that clear? Just type clear in the chat box. Clear in the chat box. Max to Pradeep Gupta is telling that place of Max, so we can use the 817. 817. I'm not sure about 817. See, I'll tell you what Max 32, Max 232 will do. Okay, it converts to TTL to the serial to RS232 or RS232. If you have a microcontroller with 3.3 volt, okay, then you have to use Max 3232. But there are a lot of manufacturers out there. I have to check the data sheets whether 817 can be used or not. But if that is a TTL converter to RS232, then you could use it. It's not necessary to Max. Max stands for Maxim Semiconductor. Okay, so it's a Max to the actually it's 232. It's sufficient. Like Max stands for the manufacturer, Maxim Semiconductor. There are a lot of manufacturers there. ILX is also there. Other manufacturer, ILX 232 is there. ILX 3232 is there. The lower price. Even Texas Instruments, they have this IC. TI, they manufacture this 232 IC. You could get from the digikey.com. Okay. Danish Ahmad is telling that can you please briefly describe the work of a crystal? See, every microcontroller will have the crystal. The crystal will give you the speed of the microcontroller. Okay. For example, this 8051 microcontroller speed depends upon the 4 megahertz to 30 megahertz. So that's the maximum speed. So crystal is nothing but you give the crystal, you give a sine signal, you give a crystal frequency. So only based on that, the machine cycle will be calculated. On the crystals, the machine cycle, the instruction cycle will be calculated. So that will execute the instructions. So if that wants to be the million instruction per second or like a million instructions or so the speed depends upon the crystal which you use to the microcontroller. Some microcontrollers will accept like 100 megahertz. Sometimes you could have 50 megahertz crystal and you could have a PLL inside, a phase lock loop inside, which could generate 100 megahertz crystal source, and you could use it to the ALU unit so that it gives more speed. Okay, 6 megahertz. Pentium 4, you tell whenever check with the PC, you will check with the 2.5 gigahertz. So that's the crystal frequency used. 2.5, you can operate up to 2.5 gigahertz speed. Okay, 2.5 gigahertz, 3 gigahertz speed, 4 gigahertz speed. You always mention the speed in terms of the crystal frequency, gigahertz. Okay, crystal is actually the heart of the microcontroller. If the microcontroller does not work, you check for the power supply. The second thing you have to check is the crystal. Okay, whether you are getting whether the clock source is whether you are getting the oscillations on that pin by using a DSO. Without using DSO, you cannot check. Okay, DSO or CRO kind of thing like that. So if you want USB, okay, you could use the Max to FT232. If you could use the FT232, it does the same thing like which does the serial converter chip. So that you could use USB port, the TXD and RSD pin can be converted to USB logic, and you could use the serial software, USB software to on a laptop to receive the data. Okay, and programming, you could use Flash Magic. Once this UART is done, then you could use Flash Magic if you're using an NXP product. Nuvoton, they have the separate ICSP utility, so you could get the utility from their manufacturer itself. And you once you connect this port, once you connect the cable to this port, like a port will be directed on the PC side. Okay, so that you have to choose, and the baud rate you have to choose. You give the crystal, the type of crystal you use, and you choose the hex file, and you could download the program. Okay, for LED interface, if you want to connect an LED, then you could connect this port 0. I have used port 0 to LED. 8 LEDs, I have connected 8 LEDs. And LCD interface, like you could connect an LCD interface like this, like a port. I will give me a moment. Let me. Okay, so for a port, this is an LCD interface here, where we have connected to port 1 and port 3. The controls like read strobe and read write or I have used 3.5. It's an 8-bit mode. You could also use 4-bit mode. 4-bit mode LCD like 3.3, 3.5, 3.6. Port 3 I have used, and port 1 is for data. Okay, and temperature sensor and buzzer sensor, like buzzer sensor, like I have port 0. I have used port 0. DS1820 is a digital temperature sensor, like I have used to port 0.0 and 0.1. Okay, so I have used a jumper to disconnect. It's a one-wire temperature sensor and 7-segment interface. Okay, these are the schematics, relay and stepper motor. So seven segment interface, like it is not needed, like we have not, it is not used in the board. This is just for a reference. Relays are used to control a 230-volt power supply. Okay, so we'll see much more detail on relays, on how relay works, what is relay and how relay works on the on we have separate session for that. So the next thing is creating the footprints. And once you create the footprints and you link the footprints, you have the unrouted PCB board like this. And you have to arrange this, and you could make it as a legend for drawing. And finally you made the bottom layer routing, top layer routing. So the last 10 days will be on this. Okay, and drill chart and solder mask top and solder mask. So what is solder mask top and solder mask bottom? Everything that will be covered up on the last 10 days. Okay, so no need to worry about this. That after that you will be fabricating fabricating this this PCB. Okay, you'll be creating the gerbers, and this gerbers you send to the manufacturers. You could fabricate the PCB. Is that clear? Is that clear? Just type clear in the chat box. Das is asking a question. Can we use the port for any other purpose other than LCD and LED? Yes, you could use. Okay. Most of the IoT works on microcontroller. That's why Karam. Most of the IoT work on microcontroller. That's why it's cheap. Okay. Is that clear? Okay, so no need to worry about this embedded system design and 851. Like we have a recap on the last 10 days. Like so on the 10 days, like you could design your own microcontroller board. I'm sure that if you are there, like you could design your own microcontroller board. And we also have a session tomorrow on the hub, how to install the software like OrCAD software and Cadence software, and how to how to make footprints and how to draw schematics and everything on Zoom platform. Okay, so sorry, actually it's a 3-month online internship program, like where we have caught up the 851 architecture, PIC architecture, ARM7 architecture, and Cortex M4 architecture, and Node MCU for 5 days, and Internet of Things on ThinkSpeak platform, Microsoft Azure platform, and AWS. Okay, so we have caught up all those things on IoT masterclass. And PCB design masterclass is about schematic capture. So after creating this, after going through this course, you'll be knowing what is Gerber, what are the layers in Gerber, what is bill of material, and how to design how to fabricate the PCB, and how to design the two-layer boards and everything that, and how to design the 851 microcontroller board. On the free session, it is also available on the free session. Okay, but here you have more support on the community. Okay. So today offer is 999. So if you want, you could enroll this offer. You got 3 course. The 4 course offer is completed yesterday. So we have stopped the offer. So you could enroll this 3 course offer, but still it's value. It's a pure value for money which you spend. Okay. So the 999 is very cheap. It's for your if you want to make your career on embedded system design, this course will fit for you. Okay. So thank you so much. I'll take questions. Thank you so much. I think today also we overlapped for 15 minutes. I'm sorry for that. So Bhavya is asking for difference between timer and counters. Timer, you could generate time delays. Okay, time delays, and whereas counters, you could specifically count. For example, to count the number of coins, or to count the number of persons who is entering the room, to count the rotation of a motor. Okay, you could use counters. By using the external pin. We have 2 timers, external pins. In that you give it to, you can give that sensor to that pin, and you could count. Okay, Whereas timers, it can be generated internally itself. No need to have the external one. You could load the data and you could set the timer, and the timer will overflow whenever it overshoots. Sorry, Kalpesh is telling 5G speed today. Sorry, I'm so sorry. I'm so sorry. Like, but still, we are not. We are running out of time. Okay. So if I am not getting to your point, you please just recap the video. The video will be available for 3 days of time on YouTube. Kalpesh, I'm sorry. So thank you, Ravikaran. Thank you, Sudhagar. Thank you, Walkemi Woduola. Thank you. I'm sorry if I'm pronouncing it wrong. I think you are from Nigeria. Garbi, thank you. Parth, thank you. And uh, does microprocessor have memory? If no, then what is the code for operation store? Mohidin, like microprocessor has, you could add the memory externally. Okay. They don't have the on-chip memory, but you could add the memory externally. There are memory chips are available on both the ROM and RAM is there. You could add them externally to a microprocessor, and you could make use of it. Okay. So thank you, Jason. Thank you, ECDA. I'm not sure what ECDA is a software. I'm talking about a software. Manasa, thank you. Priyavita, thank you. Sati Bhuvalan, thank you. Sati Bhuvalan, thank you. I think we met in IoT Masterclass. Kishore, thank you. Anzil, thank you. Thank you for Cherub. Thank you so much. Thank you for the wonderful session. Thank you so much. Ali, thank you. Can we use? Yes. See, if you are comfortable with this, there are a lot of software is available. Like if you are comfortable with that, you could use it. We have choose Cadence because I plan to choose Cadence and Altium because most of them are trying for job. The persons who are attending for this masterclass are trying for job, where most of the companies are using this Cadence and Altium and the mentor graphics. So I am planning to do on the Cadence and Altium. Uh, so if there are a lot of softwares which is very easy and to draw, but the reason I choose is Cadence Allegro is you could go for BGA. It has signal integrity. So this is a startup thing, but Cadence can do a lot more. When you come for a multi-layer board or a BGA or signal integrity, when you specially design a high-speed design boards or RF based boards, Cadence plays a major role on that. I'm not sure about ECDA. I have not worked on ECDA, EDA. So that's the reason we choose Cadence. But if you're comfortable with that, you could also do to that one. So thank you so much. Thank you so much for your time. Thank you, Dhruv Patel. It's necessary to learn 82 or we can directly jump to the latest microcontroller processor. Yes, you could also jump into Dhruv Patel. You could also jump to the latest processors. Latest processors. You could jump for ARM7 or ARM9 or Cortex M4 or ESP32. Okay, you could jump. My advice is don't go with Arduino IDE because you won't learn what happens inside, how to use these registers, okay, and everything. So the reason we kept 8051 is like you should be familiar to comfortable with to develop the code from scratch by using the registers and everything. In development point of view, like the application, if you could complete the application within like 10 to 15 minutes of time in Arduino when you use an Arduino IDE, but the same thing is not in when you use a bare metal programming, like when you write the things from scratch, like for your programming, you have to write a lengthy line for 100 lines of code or 200 lines of code. But if you want to be a programmer, like if you want to master the embedded system design, I advise you to go with the basics first. So once you make fundamentals strong, and then you could use the software what you are comfortable with. But instead of without knowing anything about the bare metal programming, like Arduino IDE will be more comfortable in writing the applications. So you could complete the applications within 10 to 15 minutes, 20 minutes of time. Like serial port with one single line, you could write serial ports. Even for the DHT11 sensors, with one line or two lines, you could read the data from the serial DHT11 sensors. But you don't know like what happens inside. So okay, so that's the reason like we start the basics on like the register level coding. Okay. So if you're But once you're thorough with this, you could go with your own. Saurabh Das is selling 82 is bit costly. No, Saurabh Das, like it depends upon the manufacturer. If you choose a Nuvoton IC, it costs you 40 rupees. Okay, 40 to 50 rupees. It's less than $1. Okay, Saurabh Deep Das. If you choose 82 like Atmal 89C51, maybe I think it's 120 rupees. Like there are some ICs if you use ICSP, Novoton ICSP with the programming facility, ICSP program, because 8089C51 does not have ICSP. You need a programmer for that. Whereas if you choose a Novoton 82 IC, you could use that cost you around 40 to 60 rupees. 40 to 60 rupees with ICSP programming, with serial port programming, and no need of programmer for that. You could wire the 3 lines and you could program through the from the USB from the serial port itself. Okay. Uh, yes, Gulkarni. All these are Gulkarni. Like all these are recorded sessions, but for you could meet me on live on Zoom sessions on every Saturday uh, on 5:30 p.m. So tomorrow we have the Zoom session on the Karim community portal. So tomorrow will be the recorded sessions. You could ask questions on the portal on the live sessions or there over there, and we will be keep on improving the course. Okay. Saurabh Deep Das is telling I am in shock. Okay, thank you. Okay. Bobby has said, so can we say counter can be controlled by software and timer is forward part? I think you're not getting the point right, Bobia. Like, see, counting is for like counter. You could count like number of events. You could count the events. Timer you could generate like on the software itself. Like, you could generate. You could also use external timers. Like, you could generate delays. Okay, the purpose is to generate delays like that. Counter you could have external counter like not on the software. You could even like you could use a timer and counter pins, and you could count, like you could give the external pulses to the software to the pins and you could count. It's not only the software, you could also use the hardware. Are in Shivu, like you the course will be valid for 1 year, so you could once the exam completes you you could learn. So the thing is to learn continuously. Okay, so you could learn anything. Which software is best for simulating? I think Proteus it's best, like Proteus, Snake Gen, like you could try Proteus. I have a drone, but it not give me a stable flight. Vinayak Sharma, I'm really sorry. Like I have not worked on the drone part. I have not worked on the drone part. Swain, thank you. Prashna Kumar, thank you so much for your time. Vinayak Sharma, I'm really sorry for this. I have not worked on the board like KK 2.15. I have not worked on the board, and I have also not worked on the drone much. Okay. So thank you so much. Thank you so much, Bobby Sevak. Thank you so much. And Arin, thank you so much. Tilly, thank you. Sri Lanka, thank you so much. Thank you so much for your time, and see you on the next session tomorrow. So tomorrow is the recorded sessions. I'll meet you on live on the portal, on the web portal, I will meet you on live on Monday. Okay, thank you so much for your time. But you will be having session tomorrow. See you on the next session. Until then, bye. Thank you. I'm signing off.